David Spears, civil engineering instructor at Texas Tech University, talking about statics, CE 2301. We're looking at a Mohr circle example from sample quiz number 4. It's a nice simple problem. It shows the use of Mohr's circle to determine principal moments of inertia and anything else, but we're going to focus on principal moments of inertia right now. Kind of these points were plotted already for us. I'm going to step back and take one step back. Normally we're just going to have the givens Ix, Iy, and Ixy. Remember, we're going to draw a graph with the vertical axis being the products of inertia, Ixy or Iuv. The horizontal axis being the moments of inertia, Ix, Iy, Iu, Iv, anything else. First thing we do is we plot Ix and Ixy at one point, and that's this point right here, 160 and 40. That's Ix and Ixy. Down here, also on the graph, wherever it lands, we're going to plot Iy and the negative of Ixy. So that would look like this point right here, Iy and negative Ixy. So I just plot those 2 points. This would normally be before I've even drawn my circle. Now I take a straight line and I connect those 2 points, just like this. Now I know where my center of my circle is, wherever that line intersects the horizontal axis, and I can figure that value, the center of my circle, very important value. The center is at Ix plus Iy divided by 2. So in this example, it's 160 plus 100 divided by 2 is equal to 130. So that's the coordinate of the center is at 130 and 0 on the xy, the product of inertia axis, the vertical axis. Now the problem asked me for, and that's the next logical step on a Mohr circle example, Mohr circle problem, is to figure out what this radius is. What this line is really the diameter of the circle. So I take a compass or freehand it, something like that, and I draw Mohr's circle of that diameter with the center at C right there. Okay, so the next thing I want to figure out is what's this radius length. Well, I can do that from this triangle right here that I'm going to draw in red, because I know these values. This value of the vertical side of this triangle is just Ixy. It's 40 in this case. This value right here on the horizontal axis is the horizontal distance from center C to Ix, which I can see is 160 minus 130, or 30. I could also figure that with the way the equation works is Ix minus Iy divided by 2. Ix, in this case, 160 minus Iy of 100 divided by 2 is equal to also the same thing, 30. Okay, now I know the 2 sides of a triangle. It's easy to figure out the radius. I can tell by inspection it's a 3, 4, 5 triangle, so I know it's going to be 50. But I can also calculate it if it's not so obvious, as that is, as r is equal to the square root of the sum of the squares of the sides. 30 squared plus 40 squared is equal to 50. Take the square root of it. So my radius is a length of 50. And now I've got just about everything I need. Figure that angle here in a minute. One of the main things I want to know from the Mohr circle is what are the principal moments of inertia. That's the maximum and minimum. Well, on Mohr's circle, those are these points out here. This is I max. This point over here on the left is I min, the minimum. And it's pretty easy to see that I max I can figure by taking the coordinates of the center and adding the radius. So that equals 130 is my center, plus my radius is 50, gives me 180. Remember, my inches to the fourth are my units. The minimum is over here on the left. It's the center minus the radius. So pretty easy to see that. Center minus the radius is 130 minus 50, or 80 inches to the fourth. So this is 180. This is 80 over here. And that's the second answer. Finally, I'm asked what is the angle theta p between the XY axis system to the principal axes. The principal axes are where I have my maximum and minimum moments of inertia, which are 90 degrees from each other. And so, on Mohr's circle, that is half of this angle right here. Remember, on Mohr's circle, the angles are doubled. So, that angle on Mohr's circle is what's called 2 theta p. And so it's the area of that little triangle, 30, 40, 50 triangle. So I can draw it down here, kind of work with it a little bit better instead of messing up the rest of my drawing. It's a triangle that's 40 and 30, and the radius is this 50 thing, but I'm not going to deal with that. So if I want to know what that angle is, from trig, I can say that the tangent of that angle, which is 2 theta p, is equal to the opposite over the adjacent, 40 over 30. So that's equal to 1.333, repeating. So 2 theta p is equal to the tangent inverse of 40 over 30, which is equal to 53.1 degrees. Don't forget, that's the double, twice the angle that I'm concerned with. So theta p is half of that, or 53.1 divided by 2, 26.6 degrees. That's the answer I'm looking for. I would also want you to tell me that it is clockwise direction with an arrow like that that rotates it, or CW or something like that.